All right, so quadratic modeling, we need to get some real life application to what we've been doing. So quadratic modeling is pretty much application problems or word problems that give us real representations of parabolas. So one thing you might think of is this guy's going up in a dirt bike. So he starts at the bottom, he goes up, and he comes back down. When you throw a ball, it goes up, and it comes back down. Lots of different examples with that. When you bounce something, a lot of the ones we're going to talk about are shooting people out of the air, like someone out of a human cannonball, or throwing a football, or this one's talking about weather. So we'll have some different examples. We're going to go through 3 of them right now, and then we'll go from there. So the first one I have for you is, at the circus, there's a human cannonball. The cannonball is situated 20 feet above the floor. The highest point that the performer reaches is 30 feet in the air. This happens when he is 20 feet horizontally from the cannon. The performer lands in a net 60 feet from the cannon. So we need to get a picture for this. So I am going to start at the beginning. The cannon is situated 20 feet above the floor. So here's my floor right here. And we said, all right, let's see if we could draw a cannon. Here's the cannon. And we said the cannon is 20 feet above the floor. So that means at this point right here, I'm going to write it as 0, 20. Because the horizontal distance, I'm at 0 here, and I'm 20 feet off the ground. And it says the highest point, so we shoot this guy out of the cannon, he goes up, and then he comes back down. The highest point he reaches, let's see, is 30 feet in the air. So we know this point has, I don't know how far he's traveled horizontally, but I do know that it's 30 feet in the air, so I know the Y. And then it says he comes back down. Oh, it does say 30 feet in the air, and this happens when he's traveled 25 feet horizontally. So this point right here is 25:30, and you might notice this is the maximum. The maximum we know is the vertex. So this is good. You have your vertex. And it says the performer lands in a net 60 feet from the cannon. So let's say there's a net right here, and the net is, let's see, it looks like that. There's the net. And it's 60 feet from the cannon. So this point right here, we don't know how high it is, but we do know that the net is 60 feet away. So the horizontal distance here is 60, 0. So, cool, there's our picture. That helps. Now it says draw a picture. We did that. Find an equation that represents the path of the performer. Well, if we think back and we want to write an equation, we should probably do it in a vertex form if we want. This is wrong. We don't know that Y value. Now, if we're going to do that, I'm going to say here's my vertex, and we also need another point. So when I write out this equation, I'm going to skip ahead to this blank slide real quick. My vertex is 25, 30. And the other point we have, we know this is 0, 20. We know after 0 seconds, we're 20 feet in the air. Or after 0, when he's traveled 0 feet horizontally, the starting point is 20 feet in the air. And then we know this is 60, something, but we don't know how high the net is, so I can't use that point. But I have a vertex of 25, 30, and I also have the point 0, 20. So I'm going to write the equation, y equals, I need an a value. I still don't have that, but we do have the vertex. And we have this point that we can plug in. So I'm going to plug in 0, 20. And that's going to give me 20 is equal to a 0 minus 25 squared plus 30. And now we can solve it out. Negative 25 squared. This gives me 625a plus 30. I have a 20 over here. I'm going to solve this out. Subtract 30, divide by 625. I get negative 10 equals 625a. We'll get a decimal for this. Negative 10 divided by 625. I get my a value is negative 0.016. So when I write out my equation, it's y equals, give myself some more room. Y equals negative 0.0 or negative 0.016 x minus 25 squared plus 30. And if you think about it, it makes sense that our a value is negative because our graph has to open down. Your parabola is opening down. It has a vertical reflection. So there's your equation. And that'll help us out because my next question says, what is the height of the net? So if I'm asking for the height of the net, that means I need to know what this thing is. But I already know that the x is 60, and you have an equation. So if we have an equation, we're trying to find what an x value is, or y value is, and we have an x, we're going to use that equation. And we're going to say, I need to know 60 comma what? And I have this equation, y equals negative 0.016 x minus 25 squared plus 30. And now if we plug in 60 for x, we're going to have to rely on your calculator here a little bit. 60 minus 25 squared plus 30. 60 minus 25 is 35. 35 squared gives me, let's see, we have 0.16 times 1,225 plus 30. Put it in your calculator. Let your calculator do this one for you. You get 10.4. Now you need to make sure you answer in the context of the problem. So it says, what is the height to the nearest foot? We would say 10 feet, since it said the nearest foot. Okay, so there's your first example of quadratic modeling. Just some real life examples of these different quadratics that we've been talking about. Another one we could talk about is football. So here we have Carson Wentz throws a 30-yard pass to Zach Ertz. Let's highlight the important information. 30-yard pass, we don't care that if it's Zach Ertz, he's hurt, we know that. The height the ball reaches, the highest height is 12 yards. You should be thinking as soon as you hear that, that's the vertex. Find the quadratic equation that models this situation. If a defensive lineman, we'll talk about that part in a second. So let's get the equation first. I'm saying here's Carson Wentz. He's throwing the ball. It goes up and then it comes back down. We're going to forget about that his hand is high up off the air when he throws it. We're going to pretend that he throws it from the ground and it gets caught at the ground. And I'm saying that it's a 30-yard pass. So that means it's traveled 30 yards horizontally. I know that the highest height was 12 yards high. And we're going to say this is 0, 0. That's where you're starting at. So we have some options here for writing the equation. Now, the one thing that you want to realize is that the vertex is always in the middle of the two x-intercepts. So here's an x-intercept and here's an x-intercept. Well, if you want to find the middle of 0 and 30 is 15. So my vertex here is 15, 12. So if I want to write the equation, we're going to say y equals a. I don't know my a, don't forget that. X minus 15 squared plus 12. Let's pick a point to find your a. You have two options. I think this point is easier than the other point. So I'm going to plug in 0, 0. I get 0 equals a. This gives me negative 15 squared plus 12. Negative 15 squared is 225. So I'm going to subtract over 12. 225a. I'll let you get a decimal for this. Negative 12 divided by 225. You get a is equal to 0 or negative 0.053. And we'll leave it just like that for your a value. So your equation is y equals negative 0.053. If you wanted to leave it as negative 12 over 225, that's also fine. And then this is x minus 15 squared plus 12. There's your equation. Now the next problem says a defensive lineman who is 6 yards away from Wentz. So let's say there's a defensive lineman right here and he's standing up. He jumps and he deflects the pass. So he's deflecting the pass right here. I know that he's 6 yards away. So this is 6. I want to know how high he had to jump. So I need to figure out this y right here. So if we have the x, we can figure out the y. We can plug in 6 for x. and then solve it out. So in your calculator, I'm doing 6 minus 15. That's negative 9. Square it. You get 81. 81 times your a value, negative 0.053, and then add 12. And we get y equals 7.707. So this said how high, it didn't specify at all. So we're going to say 7.707 yards, because remember, we're in yards for everything. And there's another real-life example of this. Now for this next one, I do want you to try it out on your own now that you've had some background. It says a meteorologist records the temperatures at midnight. It is 6.3 degrees. 6 hours later, it is 0 degrees and continues dropping. Okay, so I will help you out with the picture for this. For my picture, I'm saying we're starting out at midnight. So at midnight, it is 6.3 degrees. So let's go 1, 2, 3, 4, 5, 6. So after 0 hours, we're at 6.3 degrees. 6 hours later, it is 0 degrees. So this was 0 hours, or on our X. So I'm going to say 1, 2, 3, 4, 5, 6. 6 hours later, we're at 0 degrees. So here's the beginning of your parabola. It's going something like that. We have the 0.60, I like to label it. And then it says, as the sun, and it continues dropping, so it keeps going down. As the sun comes up, it begins to rise again. So at some point, we turn around and we come back up. And it says 21 hours after midnight. So here was midnight, 0 hours. 21 hours later, we're at 0 degrees again. I have that. And then it says, sketch a graph. We did that. Write the function. So you want to look at this, and we need to write the function. We don't know the vertex. So you might need to think of a different method. So remember, you have your two x-intercepts. Pause the video right now. Try to think of how you can get your equation. And then I will show you my answer. So I said that we have these 2 points right here. My picture's a little bit different. You have this point and this point. 6, 0 and 21, 0. We need to, in order to do this, you're going to use the method of averaging the x-intercepts. So to find the vertex, which is all the way down here, we said it's all the way down here in our picture. We average the x-intercepts. So to get the x, we do 21 plus 6, and then we divide it by 2, and you get 13.5. Okay, and then from there, we got to get the y. So you can plug it back in to get the y. If you plug it back in, we don't have an equation to plug it back into, so that's a little bit annoying. So here's what my idea is. You're going to plug in x minus 6. That's the first x-intercept. Because if you think of when you factor and solve, x minus 6 is one x-intercept. X minus 21 is the other x-intercept. We need to find the a value. So you need to pick another point. But we started out with another point. We started out with the point 0, 6.3. So I'm going to plug in 0 for x here. We're going to plug in 6.3 for y. And then we're going to solve for a. So I get negative 6 right here. I get negative 21 right here. Negative 6 times 121, or negative 6 times negative 21 is 126. We divide by 126 on both sides, and you get your a value, which means now you have your equation. Okay, we did not write this one in vertex form. I just wrote it using the x-intercepts. So I said 0.05, x minus 6, x minus 21. It doesn't have to be in vertex form. And then I said, what is the coldest temperature? Well, the coldest temperature is that vertex. It's that lowest point all the way down here. So to get the vertex, we know the x value. So we plug in 13.5. We got that from averaging the x-intercepts. We plug in 13.5 for x. And then we solve. 13.5 minus 6 times 13.5 minus 21 times 0.05, and I got negative 2.8125 degrees as the coldest temperature. You'll have one word problem on your homework tonight. You can always look back on your notes if